Hey guys, what's going on? This is Fishy and welcome back. So today we are going to continue with our project. This project is basically a 3D game. As I mentioned in the last video, it is a boat game. So you drive your boat through the river and that's how you keep going on. It's an endless runner, endless game. And last time we discussed how to procedurally generate any terrain. I was showing an example last time from a YouTube video actually, uh, created by DevPoodle, I guess. Yeah. So this video or today we'll look at how to create this particular game. So how I went about creating this and what were the challenges that I faced and how did I overcome them. Some of the performance issues, we'll discuss about those. So let's get started. So as you can see, last time we went through this node tree as well. I have a directional light here which I showed, then I have a boat camera, and I have this terrain. So this terrain and these meshes here is what I am generating, and that is what creates that endless river effect. And these are just side fillers so that when you are looking at the camera, I think I mentioned this last time, through the camera you don't see any blank space. They just fill your FOV or field of view. That's what that is for. Let's look at the terrain now. And all of this, as I mentioned, is controlled by this script right here. I should attach a script on this node, but yeah, I think I'll do that refactoring some other time. But for now I'm working with this. I have made it a tool script just to mess around with it in the editor, but now I don't need it. So definitely when you try to publish your game or app, then don't do it with the tool because you don't need it. Actually it won't make much difference. I don't think it makes any difference, yeah, but better remove it, I guess. Not really sure about that. Then I have these two nodes in the game, in the script, so that I can change them. I can change properties on them. Camera, I don't think I'm doing anything with the camera. I can actually remove that. And boat, I am moving. Yeah, so boat I am moving. I haven't really figured out how to control the boat yet. Like I've not decided on it, whether it's going to be like a swiping motion, so you swipe and the boat moves left or right, or whether it's gonna be like buttons, so you mash the buttons, move it left or right. You have buttons on both sides. Yeah, not really decided on that. Then I think we saw some of these variables last time. Okay, so before we actually go into the script, and actually I went through the other script right last time. So there we looked at this mesh creation, so getting all these arrays and then creating our final mesh, array mesh from those arrays. So main thing, as I mentioned last time, is calculating the heights, right? So here it looked quite simple actually in the beginning, but turned out to be quite a challenge. We'll discuss the details. So all I need to do is, at a given x, so x is this axis, at a given x I need to see whether on at this x, what is the left and right z. So z is this axis, the blue one. What are the limits of z on the left and the right within which the river is present, and there I need to set the height to -10 is what I went with. and rest of the points I went with positive 10. And you can see some, you know, curve here. It's not that smooth, but it is a curve. I'll talk about that later, at some point later. I'll talk about that, but for now let's consider that you have z here for a particular x like this. You have one z here and one z here, and if my point, the vertex for which I'm calculating, lies in between this region on that x, for that x, then I need to put set its height to -10, otherwise it's +10. So that's how we keep going on. So for each x I had to calculate the range of z within which the river lies. That's how I went about doing this. There might be other ways, but I didn't figure out, and even this approach I came to it with after a lot of trial and error. You know, I tried different ways. So how do I do this, right? So the approach that I took was something like this. So what I'll do is I'll and this is something I did initially. This is not the final thing. Final thing is kind of close to this, what I'm about to explain. So what I did is I start from origin 0, right? So my z, what I'm doing is actually calculating the z value, which is along this blue axis, at every x. So what I did is I have a loop here that goes all the way to the length of a section, and this section thing I'll talk about again. So I'm not doing it continuously, I'm doing it in pieces. That is for performance, but we'll talk about that at the end. So I have z, I begin with z equals 0, so that is at the center of this section. My section is from here to here, right? Other things are the fillers. So I start from 0, then I go one step forward and I need to calculate the z again. That's how it is. Now how does z change, right? So z changes based on the angle of the river, right? So angle of the river should it might change, it might keep changing, or it might not change, but whatever the direction the river is pointing towards at that particular x, that is how I find out the next z. So let's say, for example, we are here, right, at this point. Now my river is pointing in this direction, right? So my next z will be somewhere here at the next x. So x is one step forward here and my z will be somewhere here. So we are actually subtracting from z, as you can see at this point. And similarly, if my river is going in this direction, then we are adding to z at every x, right? So that's how I calculate. Now how do I calculate the angle? So actually I have two states for the river. So there is a concept in programming called state machine. I didn't really create a state machine here, but it is just two states, right? So I am just using a Boolean expression for that, and that basically what it does is, so my river can be in two states at a given x, which is it's either turning or it's not turning. If it's not turning, then it's going straight. As you can see, this section river is not turning, and then this part is where the river is turning, right? And then again it's not turning. So that's how it keeps on going, right? It turns, goes straight, turns again, goes straight. Now when does it when do the states change, right? So states change only when, so there are actually two conditions. I put one later on. So the main condition is that this bank width, I call this bank width, when it hits the minimum bank width I can calculate based on the z, right? So let's say here z was 0, then it keeps on decreasing and it hits the minimum bank width based on the total length of this section. I subtract, and by the way we'll go through the code for this in some time. So I subtract the river width. I know the river's width as well, so I can find out this bank width. And when it hits minimum, I make the river turn. I say okay, now start turning, and what angle to turn to is something I calculate randomly. And another state machine is left and right. So if this right now river is going towards the left, then when you are supposed to turn, now you are supposed to turn towards the right. You can't turn again towards the left, right? Then once you are right, then again you have to turn left, and like that it keeps going on. So also, yeah, so once it hits the bank, it starts turning, and if it was going left, it will now go towards the right. So two states are changing here. Once it has turned to that angle, which I decided randomly between some 20 degrees and 60 degrees, now it is going towards the right at that 20 to 60 degree angle, some random angle, and then it keeps on going, again hits the bank, again turns. Another condition is, yeah, I just put it because 20 degree angle, and if I am like here at 20 degree angle, it can go on for quite a long distance. So I put a condition that okay, either you hit the bank or you have traveled 80 units along x. If you have traveled 80 units along x, then you have to turn again. That's just a small edge case condition. So it keeps turning that way, and it has worked out quite well. So I'll show you later on that the river becomes quite unpredictable and it's quite random. So that is good. It's not like a single monotonous, turning left right at the same angles. It's not like that. So it's quite random. So that random angle that I set is what changes the shape of the river as we go along. So yeah, that's basically the way. Now few challenges that I faced, so let me just go through them briefly. I actually have a sketch here in Inkscape. So, and Inkscape, by the way, if you don't know, is a good SVG tool, so you can edit SVGs using it. It's for vector drawing. So yeah, okay, so let's say this is the z that I calculated, right? I explained about z. I have an angle, so I keep going along that angle and calculate the next z, then next z, next z. Like that, I have points along this curve, let's say. Okay, this is the curve I come up with. Now I need to calculate the left and right limits, and using those limits, I'll set the heights of the vertices, right? That was the plan. So if I do, so initially what I did was, I have a river width, right? And what I did is, at any x, I know the z. So this is my middle point of the river. Now from there, I go width by 2. So I have set a river width. Actually, you can see it. One sec. So that is right here. Just to play around with. So it's 35 now. So I go 35 by 2 to the left and 35 by 2 to the right. Easy, right? That's how you get the width of the limits. So z left and z right. and then you can set the heights. But that's not how it worked out. So basically, if you see here, so I created a copy of this curve, and if you see, if I initially, let's say it's here, right? Now if I shift it towards the left, so watch what happens. So I have shifted it a certain amount, right? Let's say width by 2. So as you can see here in these sections, it's quite narrow, right? And at the curves, it's quite broad. As you can see here, it's quite narrow, then here it is broad. So why that is, right? So because that's basically because, as you can see, it's not about shifting the curve to the left or to the right. If you look at this model, this one as well, the outer edge, right, for any curve, the outer edge is turning quite slowly, so it's a smoother curve, right? It turns quite slowly, then achieves the angle that we wanted, the random angle from 20 to 60 that we are setting. But for the inner edge, it's quite a sharp turn, sharper than the outer edge, right? It turns quickly, it covers less distance as well. So this is a longer distance, this is a shorter distance, and then it achieves the same angle again as the outer edge. So that way, this width, right? So let's say this is the angle along which the river is going. This width, the tangent, or you can call it a normal. So let's say this is the tangent, then this is the normal. So this normal width is supposed to be constant, and that is and what we were doing is we were setting this width to be constant, which will be wrong, right? As you can see, if we just calculate the horizontal width at this point, let's say this is the x-axis, right? So we are calculating z. This is quite long, you see, this length, and it is the same as this, right, along the horizontal. But along the normal, it's quite short, which is wrong, right? So we want to keep the normal width constant, and for that I just applied a formula. So I'll show you here. I have this diagram, right? So this also gives you a good picture of like how z is changing when it turns. So it's turning towards the right, and initially it's straight, then it turns a little bit, I will call it delta. So it turns delta degrees towards the right, and it keeps turning until it achieves the final angle, right? So delta towards the right, then another delta towards the right, and as you can see, this point is moving towards the right, the middle point, right? And if you look at the edges, so these are the normals, and these are of constant length, and this is what we want, right? The width of the river, this is equal to the width of the river. So as you can see, these points are quite close together, and these outer edge points are far apart. This is what we want to calculate. But what I need is at a given x, because for a vertex we have what do we have? We have x and z, and we want to calculate the y, which is the height. So I have x and z for a vertex. Then I'm not going to go along the normal, because when I go along the normal, let's say here I have my x and z coordinate here, so this vertex I need to calculate the height. I'm not going to go along a normal angle and then find out this point and then see if what is the distance along the normal with this point. Those calculations will be very heavy. They'll take a lot of time. So initially what I did was I went some distance up along x and some distance down, and then I calculated distance from this point to the z point that we had, and what is the shortest distance, so that will give me this, right? That's how I did it. And this distance, shortest distance, is supposed to be less than width by 2, and if that is the case, then yeah, it's inside the river and you set the height to -10. So I actually was going for this length, right? This length is supposed to be less than the width of the river by 2. Now going some x up and some x down and trying to find the shortest distance from any z is not the way to go, because that slows it down quite a bit. So the calculation, the for loops, they become quite large, and then the game was basically stalling and stuttering. So that was no good. So actually there's a simple solution. As you can see here, if I'm talking about this x, so this x is same as this x, right? And as you can see, that this is a right angled triangle, right? Actually we can, yeah, this is a right angled triangle, and this theta will be equal to the angle that we are talking about, this the direction of the river. So it's a simple calculation. I did it on paper, but I'll show you in the code to get this distance. So you know this distance based on the z, and then from that you can calculate the hypotenuse based on this angle here. So this tangent's angle we know. That's how I went about doing it. It's quite simple actually. I'll show that to you in the code. Okay, so this is basically, these were the challenges, you can say, and let me just show you what I did at the end. Before that, let's talk about some optimization challenges. Okay, so basically what I wanted was that I want the terrain to move, right? So the terrain should move, my player should not move, because in case of an endless runner, I don't want the player's position to keep on going to very large values of x, and I don't want to deal with that. Let's say x goes out of bounds, I don't want to deal with all those things. So that's why I want the player to stay at the same position, camera as well to stay at the same position. Player will only move side to side as it has to, and the terrain will move backwards. So that's how we create the effect of an endless runner, terrain moving backwards. Now how to, first of all, moving the terrain backwards, that's simple, but how do we keep on generating the terrain, right? So that's where these sections come into picture. So if you look at this, so I have total of 10 sections, each has a length of 30. How I set this is basically I played around with it, how far the camera is reaching, and is it able to go past the last tile. It shouldn't go past the last section. That's how I set this. And you want the lengths to be short so that it takes less time to calculate each section. Okay, but not very short, of course, because then it will take a lot of sections to build up your whole mesh. So yeah, you need to just play around with that a little bit. Width I set as small as possible. So width actually is my wiggle room for the river, right? That's how much the river has freedom to turn and twist. So I just set whatever least I could set, right? And yeah, rest of and then rest of the space I filled up with these side terrains, right? Then comes the resolution. So resolution is basically in how many parts are you dividing your mesh, right? So and that applies to each section. So this also I can't have a very big value. Big values will definitely add more smoothness to the curves, which I don't need. First of all, a lot of smoothness, and second of all, this will increase the number of vertices for which we have to calculate the heights. So if we have to do that for each individual vertex, right? So that becomes quite a lot of work. So to speed things up, you know, keep things normal, I just set it to 300. That works quite well for now. We can reduce this in the future if we face any performance issues. This is a factor. Then curve delta is like how quickly the river turns. So I kept it to 1. This is actually 1 degree, and yeah, this works out well for now, so I just left it at 1. Then river width is 30. I set it as an initial value of 30, but right now, as you can see, it's set to 35, and this is actually what will take effect if you play the game. So don't get confused by that. This value is like an initial value, but this is what counts. Okay, and then we have a ground texture. So this is the texture that I'm applying on the mesh that I'm creating as we go along. So all the meshes get this texture. Texture is nothing but a lot of properties in this, but mainly what I'm doing is setting a color. You can set other textures as well. I tried this out. This is like a rocky texture, but it's quite photorealistic, which is not what we are going for here. So yeah, actually I can apply it and show you. So okay, yeah, this is the texture, and then this is the normals. Okay, I think I need to set the scale right, so give me a sec. Inside the texture, no, not inside the texture. Right here. Okay, so maybe it to 5. No, yeah, now it looks little better. Even though these textures are looking quite weird, but as you can see, this is like a realistic ground texture. Again, I need to play around with the scale a bit. So you can apply such textures as well, but we are not going for like a realistic thing here, so I'm just going to set it back to what we had. Okay, what did we have? It was green, so okay, I guess this is fine for now. Okay, so this is kind of what we had. So now that we have this, let me just yeah, I was going through the code, so let me just do that. Okay, so this is my array, this is my list of river heads. So I call this the head of the river. So like I'm generating the river, right? So what is the last point that I have generated or I have calculated, right? So this is what I'm the z points, the middle points of the river are called river heads, and then tangents are the angle that we were just looking at right here. So this angle is the tangent, and tangents I am storing as vectors. So vector is nothing but it's a point in either 2D or 3D space, but here what I'm using it for is not for its length. So length, when I say length, we are calculating it from the origin, right? Origin to that point. Length, I'm not worried about that. I'm worried about the angle with respect to x-axis. So 1, 0, right? And we are talking only in 2 dimensions. Even though this is a 3D game, but my river is going in 2 dimensions, right? It's not going above. It's not going to go up. So yeah, we are talking in 2 dimensions. So these are 2-dimensional vectors, and these are just values, z values of. So this is actually in 1 dimension, because for an x, so x will be the index of inside this array. What is the value of z, right, along the width? So that's how this is. And same thing for this, or at an x, at a value of x, which is the index of this array, what is the value of the angle or the tangent, right? That is represented by a vector. I could have stored angle values like in degrees or radians, but I don't know. I think during the process I needed it as a vector, so I did it. But definitely I think we can store degrees or radians here. That will also work. Okay. So then these are the values that I am using. I think I talked about these. So these are my states. Whether at this point I'm going left or right. So initially these are set to true. He's left and turning. For the initial section, which actually ends right here, I didn't let it turn. Basically I said is turning to false just for that section, so that initially it's straight and then it starts turning. So then as you can see, it's left, it will always turn left since is left is true, and then it keeps going on. Current curve angle is again it's actually a value from 45 to 60, but I'm calling a function to reset everything. So I need to actually reset everything at the beginning, and some of the things I need to reset for each section, but we'll come to that later. So okay, I have the river head z, which is the current river head. I can actually use the reason why I'm using this variable is, instead of just getting the last element from this, is that I have to empty this for the next section, but I need to know where the last section left off, right? What was the last z of the last section, and then continue from there. I can actually do that using this and not have like a global variable. But yeah, for now let's say we have this global variable. So I do this position x. This is basically section length by 2. So I actually need this. We'll see where I need this, but I need to move the sections forward a bit. So actually initially all of these sections are at origin, which is right here. Then I need to move them a certain distance. That's what this is for. Then child node is actually this I don't need. Okay. This is just this node which I initialize here. So we'll come to these parts, but I initialize it here. So you do get node with the node name, and you get the node here, and that is where we add the mesh instances. Then comes mesh array. So this is where I'm storing the meshes that are currently in the scene, okay, which is 10. This will always be 10. Then comes mesh repo. So for performance reasons, I am keeping a repository of meshes that can come after we remove one of these meshes. So when do we remove the mesh? So as I was explaining, right, we don't move the board, we move the terrain. Once a section moves behind the player, I can remove that section, right? I don't need it anymore. It's not even visible, it will never be visible. So I remove that, and then at the far edge I add another section, right? That's how this process keeps on going. So you remove a section, you add a section immediately, right? But calculating that section takes time. It actually is a bit of a process, and when that process happens, the player and the scene get stuck for just a second, but still that's very annoying and it's not really a good experience. So you're moving and it gets stuck since it's calculating the next section and adding it, and that time reduces if you reduce the section length, you know, create smaller sections so that it's quicker to calculate them. But still it's not a good experience since it stutters a bit every few distance you go, right? A little distance you go, it's supposed to calculate the next section and it just stutters. So that's why I am maintaining a repository of sections of size 2, which keeps 2 sections as a buffer and then keeps adding them. How do I maintain this repository? Is through a thread. Okay, why use a thread is because I don't want the main game to stutter, right? Simple. So I offload this work to another thread which does not interfere with the main game thread, and that way main game thread keeps on going, does not have to worry about calculation of the mesh instances, right? And that way there's no stuttering. Okay, I'll show how this thread works. Then distance no turn is again, as I was saying, there was an edge case where if it keeps on going a certain distance without turning, then I force it to turn even though it has not hit the minimum bank distance. So to keep track of that, I'm calculating this. So how much distance has passed, how much x we have traveled along the x-axis without turning. So that's basically it. I think a lot of the things have become clear with that. This seed value I kept because I want, so basically what I'm doing is initial 10 sections I have already calculated, as you can see, and I am storing them as part of the scene so that initially I don't have, when the game starts, I don't have to calculate 10 sections, and that will take time, right? It actually takes like 1 second per section, so like 10 seconds. So if you start the game and you're creating the initial sections, the player has to wait for 10 seconds and then start the game, which is not a good experience. So even though this initial part will always be the same, after these 10 sections you will have random sections, like randomly the river will turn and keep on going, but this initial part will remain quite same, and that is where we want, this initial part is where we want it to be predictable. That's why I set a seed value, so that so that these turns that we are looking into, right, the curve angle, they are the same as we go along. And what I do is, initially when I calculated these 10 sections and I stored them, I also stored the variable values. So all of these values I have actually stored at this point, right? So when we reach this point, what is the head of the river, what is the tangent, are we turning at this point, which direction are we turning, left or right, all that state data I have stored. Okay, so what I just do is, when the game starts, I have everything calculated up to here, and I just initialize the variables from here and then start calculating further. It's quite simple that way, because I don't want to calculate from here and then reach here and then continue from there. It's not like that. So everything is calculated up to here. Till here, what has happened, I don't care about that. I actually dump all this data, these tangents and river heads. These I only need for a particular section. So I calculate these first and then I calculate the height for the mesh array, right? We'll see that code below. So after that, I then discard them for that section and then start a new for the next section. But these things carry over section to section, right? What is the direction? What is the curve angle? You can be turning and change a section, right? When you are in the middle of turning, section gets over. So these things carry over from section to section, the river head, right? That's basically the, yeah, that's all basically the logic of the things. This part is for the initialization. So this does not run when the game runs. This is just for calculating and creating these 10 meshes. Okay, so I just see if this has no children, I run it. Actually, I can do it right now. So if I delete this, okay, and in here, as you can see, nothing is left. And then what I need to do is, I'll do it within the tool, within the editor itself. I don't need to run the game. What I'll do is I'll change something. Let's say, for example, okay, this init delta, curve delta. Okay, in the set method of curve delta, I have this init sections uncommented. I commented the rest because I don't need them. But when you set the curve delta, this function will be triggered, and that is basically the entry point for the whole thing. So it will call this init sections and it will see, okay, there are no children. What it will do is it will reset the vars from the beginning, right? From origin. So z will be at the middle, initial tangent will be pointing towards x-axis. So that's how it is, right? And then total sections was 10, so we'll calculate those initial 10 sections here, right? That create mesh is here, where we actually do all the calculation for a mesh, and that only does calculation for a particular mesh. I have a print statement here calculating, creating mesh. Those we will see here in the output. And let's just run this. Okay, so actually it's a little bit janky, so I need to change the curve delta to 2 so that it creates. Then I'll do it again, set it back to 1 so that we have something created with 1. Okay, I just did it that I am just doing it that way. Maybe there is a simpler way, but anyways. So when I have clicked, actually I have changed it to 2, and as you can see, it's the editor is taking some time to create the nodes. Okay, so here it is. So it has created those 10 nodes, and actually because there is a thread, it has also created the repository, the buffer mesh, but I don't really need these, so that is fine. Okay, these threads I am starting here, which is after all this. So what I'm doing is I'm creating the 10 nodes and then I'm saving the variables after creating the 10 nodes. So for the 11th node, where do I need to start from, right? That is this. And then these variables I load if I am not creating the mesh again from scratch, right? That is when I load the variables where we left off after 10 sections, and then continue from there for 11th and 12th sections. Okay, and this part is just to let's say this else block is basically if we already have these 10 mesh, right? So this for loop is basically to load those 10 meshes into our mesh array, and then it that array is basically a roller, right? So you remove the last node if it passes the player, and then add another node at the beginning based on, and you calculate the position, like what is the last mesh position, and then place the next node or next mesh after that last mesh, right? That's how it is basically maintaining that mesh array. That is being done here, mesh array, right? And this part is just for sorting, so that the order of the mesh we can maintain. If you just run this this loop, this is not enough. So child node dot get children, I just want to make sure that things that are inserted in the mesh array are actually in order of the position, right? This should be index 0, this should be index 1, this section, the next section should be index 2, and so on. Okay, now this doesn't look good because its delta is 2. I'll set it back to 1, but before that again I need to delete these. Okay, so I delete these, I set it back to 1. Again it will take some time, it gets stuck. Not really stuck, but it's doing the calculation and main thread is busy. So okay, actually we overshot here, as you can see. So this is where my side terrain ends, and yeah, so that minimum bank thing didn't quite work out here. I have to check why. I think because we turned quickly here, and then we were supposed to turn back towards the right, but then we ran out of space. Okay, so yeah, I think I can adjust some things. Let me see. Minimum bank width we can change, I guess. Section width also we can change. Let me change that here. So let's say 250, and I don't have an exported variable for bank width, so let me set that to I guess 75 should be fine, because I increased it by 50, so I'm increasing this by 25, so half of that on both sides, because this works on both sides, right? Let's create it again. So we go back, delete these, and then curve delta. So curve delta, it's calculated. I don't want it with 2, so I delete these again. I think I'll look for a simpler way to do this, but yeah, that's how it is for now. And the wait time, you know, things getting stuck, can't really do much about that, because it will take time to calculate all those 10 meshes and their heights and everything. Yeah, that takes time. And okay, so we have something here, and as I was saying, this save part where we save the variables, that gets saved. So basically I'm creating a dictionary, and then key values I'm inserting into this config file, and this config file is actually here. So config file I declared somewhere here, let me see. Path. So this is the path, and I'm saving it as a resource, because when I export the game I need this to be there along with these meshes. So these are part of the game, they are not calculated, or they are not user data, they are game data. So I want them to be here, and every time, that is where it will start from, right? So that's basically how I create these sections. Let's just see what else we need to go through. So saving the variables, loading the variables is all here. Resetting is only this won't happen. Reset is only used when we were actually deleting and recreating these mesh, but we don't need to do that anymore. Maintain mesh repo. So okay, this is where this is what we run from the thread. So if repo size is less than the actual size is less than the repo size, then we create a new mesh and put it in the repo, right? And then this is where we remove the last section and replace it. Once a section moves past the player, we remove it. So that is here. Okay. So add section, remove last. When is this triggered? We'll see. But basically what we do here is we take out the a mesh from the mesh repo, the first one, and then remove it from the repo. Then we start the thread to calculate another mesh, put it in the mesh repo. That this thing happens asynchronously, so we're not getting blocked. We move forward while this whole thing happens, and then we just place the mesh properly. So you put the mesh that you got from the repo in the mesh array, set its position based on the last node in the mesh array, that is set its position based on the last node and the length. So you're just adding length to the x position of the last mesh, right? Or the second last mesh now, since our new mesh is the last mesh. And then we actually add it to the tree. That is happening here, right? So child node is this terrain node, and we add it as a child, this new mesh, right? This is important. That is when the mesh will actually become visible in the scene, right? And then this is the removal of the mesh array 0. So the first mesh that has gone past the player. And this part is quite important. So remove child is fine, like you have removed it from the tree, but it is actually still present in the memory or in the game. It's not visible since it's not part of the scene or the scene tree, but it is still available to us. So we need to free it from memory, from everything, so from the game. So this is where it will actually get destroyed. Okay, so this part is quite important. And then even if you don't do this, it's quite easy to miss this, because the mesh actually will go away from your scene. You won't be able to see it, but memory will keep getting piled up since we are endlessly creating meshes. So this is very important. And then mesh array dot remove at 0, so you actually remove it from the mesh array. So now it's actually gone, right? Now current section +1. So how many have we generated so far? I don't think this is needed anymore. Let me just see. Yeah, I don't think I'll use this, but anyways, I'll check on that later. Now move terrain. So this is where I'm reading the inputs. So let me actually just run the game and show you. So it's saving the scene, since there are a lot of mesh elements, taking some time to save. But starting above the game will be quite fast since we already have the meshes. And now what I've set it to do is, when I press the arrow key up, the mesh moves back, right, as I said. And arrow left and right I have set to move the boat. So as you can see, this capsule is moving. And forward, right now it just goes through the mesh since it's not interacting with anything. I have not set those triggers. And creating mesh 10, as you can see, it just this is something that the thread is triggering. Okay. It's basically just keeping the repo size. It's maintaining the repo size, right? So as you can see, as I go forward, these meshes are getting created and they keep on getting created, so it's working quite well. I'm pretty happy with it. As you can see here, again we have hit the edge, so I need to do some more calculations for that. Make sure we don't run out of space on left or right side. I'll be doing that soon. But as you can see, it's working quite well. I'm pretty happy with it. If we want to stay within the river, we can do that. And no real performance issues that I can see. It's stopping in between because I'm pressing another key and it stops. So I need to adjust that as well. But anyways, moving forward is not something the player has to do. I just did it right now for testing, for seeing how this river endlessly keeps getting generated. But yeah, I think it's working quite well. Okay, let's stop this. So input, these three are what I was talking about. Up arrow moves the terrain back one unit, so we can increase this to increase the speed of movement, but right now I've set it to 1. Anyways, this is temporary. And then boat position, we change left or right based on the key press. It's quite simple. Now move terrain is something where we have that logic of removing the last mesh, adding a new mesh. That is happening here. So with this we have already seen. And moving is simply moving each section. That is this for loop, each section by a certain distance, which is 1 for now. And then last element, if it moves past the origin 0, then we remove it. Okay. This is the function to set the new curve angle. So now this is, we are talking about turning of the river. So what is the angle to which it is supposed to turn? That is between 20 and 60, as I mentioned earlier. That is being set here. Where this is called, we'll see. Actually, yeah, let me go to the actual create mesh part. So this part we are already quite familiar with. This for loop is what I am running to calculate the river heads, which is the middle points of the sections. And then quite a lot of logic here, so let me just go through it. So along the section's length, which is along the x-axis, I am going point by point, so moving by one unit along the x-axis. And we push the current river head, which will be initially 0 if we are talking about the first section, right? So initially 0, river direction is pointing towards the x-axis, so it will be 1, 0 actually. Let me just see. Yep, it is 1, 0. So it's pointing in the x-axis, x direction, length 1, and y component is 0. So it's with respect to y-axis, it's at 90 degrees. Right? Or in this case z-axis, but when we are talking in terms of 2D, we can call it x and y. Okay, but in terms of 3D, y is the height. Okay, so it's xz plane. Then current section equals 0. Then I say continue because I am not turning anything in the first section, so that's why this thing is there. The 0th section is always straight, right? Then we can ignore this. Then for any other section, we have these two, this state, right? So if it is turning or if it is not turning. Okay, if it is turning, then what we do, we update the direction of the river which is simply rotating this vector. This was a vector, as if you remember. So we rotate this vector either in the left, so it will be minus curve delta, or in the right, plus curve delta. And curve delta is just 1. So it's 1 degree. So we need to convert degree to radians and then rotate this vector by those many radians, right? And then normalize is nothing but, as I think I mentioned it in the last time, so it's just setting the amplitude or the length of the vector to 1. Since we don't care about the length, we just care about the direction with respect to the y-axis. Okay, so this is how we calculate the new updated angle as we move along x, right? So this is the new direction. Then what do we do? This is the end condition basically, so when to stop turning, right? So what do we see? We see if it is going towards left and this angle is less than 0. So river direction basically less than 0 in the sense it's pointing towards the left. It is actually pointing towards the left basically. With respect to x-axis is what we are calculating here, the angle. So if you see the documentation of angle, it's giving us an angle with respect to positive x-axis, which is 1, 0. So we were initially 1, 0. So we are starting from 0 degree and we go minus 2260 or plus 2260, right? And then if it is not towards the left, then it has to be greater than 0, right? And the absolute value is greater than or equals to the current curve angle. So this basically we did to take care of the sign, either it is positive or negative. So it is having the correct positive or negative sign as it is supposed to have. And then since this does not have the sign, right, it does not tell you whether it is positive or negative. It's just some value between 20 to 60, right? So, and this thing will tell us whether it has reached that value or not, 20 or 60, 20 to 60, whatever, let's say 30 degrees. So whether it is now 30 degrees or not. If it has become equal to 30 or it has passed 30, then we can stop turning, right? And if it is not turning, then we just go in a straight direction, right? We just keep going in a straight direction. This is that no turning one. So this is like we are going too far along the straight line and we now want to force a turn. So that is this condition. So distance no turn, you keep on adding if it is not turning. So you're going in a straight line. Then if that crosses the threshold, then you set it to 0 and you make it turn in the opposite direction. And then you calculate a new angle to which it is supposed to turn to, right? That turning will happen again here. And then this is the bank width condition. So again, this is again similar to this. So you're supposed to turn, so you're not turning and you have reached a target bank width. So getting current bank width is again simple, just whether you are on the left or the right, which side of the bank you want to calculate. Based on that, these two are there. It's quite self-explanatory, like where you are at, what is the section width, and then what is the river width. So that remaining portion is your bank width. So you get the current bank width if it is equal to the target bank width, which I have set it to minimum bank width. I was planning to like vary this as well. So randomly calculate a value, set that to the target bank width. So within a range, like calculate, have a value and then set that to target. and then based on that turn the river. So there will be more variation in the curvature of the river. I might do that later. Then again turn it the other way, right? This is quite simple till now, I think. Straightforward. Not really straightforward because it took me some time to reach here, but yeah, I think it's all clear till now. So river head Z, now we calculate the updated head. Okay, so we did what we had to do with the angle, but whatever the angle is, whether you're turning or whether you're not turning, you are going forward, right, along the x-axis. So you do need to calculate the new Z, whether you're going left or right. So that is done based on current river direction. So river direction is our vector, right, the tangent. So based on that, whatever that is at this point, whether you're turning, going left, right, whatever it is, this is the direction, and based on that you add. So tan of that I am adding right now. Even here I could have used some delta or something so that, you know, but actually I shouldn't, because delta this I'm calculating based on x equals 1. Moving x1 forward, Z left or right. So you can imagine a right angle triangle where perpendicular is x-axis along x, which is 1, and then you need to find the base. So perpendicular by base is tan, right? So tan theta will be your base, or you do it the opposite way. So x is base and then perpendicular is the Z. So then perpendicular by base, so perpendicular by 1 is tan theta. So that tan theta I am adding here, right? So so that is how it is, right? So that is why I am adding tan theta and not multiplying it by anything. Then that way you get the new Z, river head Z, and this will also take care of the positive and negative you need to add or subtract, right? So moving left or right. Now we have river head Z and river direction. I actually did +1 here because when we do this epsilon thing, right, I put epsilon to 1, we might overshoot the length, right? So if you are calculating, let's say here at the edge, the normal, then in the last video I mentioned that you go 1 beyond and 1 back, 1 unit forward, 1 unit backward. When you go 1 unit forward, you overshoot, and then I was getting errors out of range. So I calculate 1 more, but then that 1 more is for the next section, right? So we need to leave off in this section, right? And the next section calculation will happen from there. So I said these will carry over. So since these will carry over to the next section, I set them to the last node of this section, current section, which is second last element from river heads and tangents. Okay, so using these river heads and tangents is now how we will calculate this height and normal. So even normal uses height, right? And actually the normal function is same as what we saw in the last video. I didn't change this except set epsilon to 1. Doesn't make much of a difference because resolution for my case is anyways like 1. So okay, resolution is not 1, but I am calculating for each single unit. Okay, now height is important. So for any vector vertex, given its x and z, we need to find the y and set it. So this get height is where things get interesting. Okay, so as I mentioned, if we go back to this diagram, I need to find the horizontal width of the river, right? And as I mentioned, if I am at this point, I know the direction. Based on that, I will calculate this width. I know the normal width is a constant value. Then I calculate this particular width. Okay. And then I have at an x, I have right side z and left side z. Sorry, left side z and right side z limits. And then based on that, I know where to go, right? So for a particular x, first of all, new x is it's basically section length by 2. I have to add to x, and this seal I am doing because in normal sometimes this, and now I have set it to 1, but earlier it was a fraction, so x was not exactly an integer, right? It has to be a integer without any decimal. Since I am going to use this to get the tangents and river heads at a particular x, so I am not having values in these arrays. So x is the index, right? And index is supposed to be a whole number. It's not supposed to be an integer. It's supposed to be an integer. It's not supposed to be having decimal value. So yeah, that's why I use this seal. And since section length by 2, I had to add because from 0 I am going to section length, and the index, this x values for that calculation that we are doing here, the vertex, they go from minus section length by 2 to plus section length by 2. Okay, so section length is 30, then in x will be minus 15 to plus 15. I don't want that because my river heads and tangents are from 0 to 30 section length, right? So this is for that. Then these are just edge scenarios. They might overshoot, but I don't want to let them in any case. Then new width. So this is where that thing I was explaining about, with respect to normal, we need to get the horizontal distance or horizontal width of the river, right? And it should not be like this, right? It should not be like this. It should be based on the normal width of the river. Okay, so this is the normal width, actually by 2, and then I divide it by cos of the tangent. So I did this actually on paper. You can do this on by yourself as well. If this particular angle, right? So this is x-axis and this is the angle that we are talking about, theta. Then you have this. That is what you need to find. This width based on this you know, and this is what you need to find, the horizontal width, and this is the theta that we have. So this angle, small angle, will be equal to this angle with respect to the horizontal. So you can apply this formula and you'll basically get this. And this is what I have done basically for creating that little bit of curvature, which is quite rough right now since we have less vertices. So this curvature which you see here, and you'll also see it actually here if we look at the cross-sectional view, this is what is being done here. So I'm just seeing if it's like right on the edge of the river limits, right? With respect to new width, I know the limits. So this is actually not the whole width, this is half of the width on both sides, since we are doing by 2. So I subtracted from river head z, so the z is the middle point, subtracted so you get the left limit, and added so you get the right limit. And I'm just seeing if z is like close to that, So if it is 1 units far, 2 units far, or 3 units far, based on that I set some heights 2, 3 and 4. So a little bit more up further from the edge of the river, it has more height, and gradually it has 5 height. So 5, 4, 3, 2, it comes down like that, and then here it is -10, which is this. Okay, so yeah, that's pretty much it. Then we get the heights and then we get the mesh, and that is what we return to be added to the mesh array. So yeah, this is basically what I have done so far, and it was nice sharing that with all of you. Let me know in the comments if you have any suggestions. Please go through this code. I'll also put the link to the GitHub for this code in the description. You can find it and you can go through it. It's public. So I will do more changes on this.